Good afternoon, everybody, and thank you very much for stopping by our booth here at Dental Wings at IDS 2017. We'd like to take just a few moments of your time and explain to you some of the newer technologies we're presenting here in our dental suite. Obviously, in the middle of the suite is our intraoral scanner. We'll get to that in just a moment. I want to explain some of the technologies we have wrapped around back here. First, of course, is our laser mill. This will be coming to market this year in 2017. This is a milling device that'll take a block and turn it into a dental restoration using just a beam of light. No burrs, no spindles, no fluids. Very little maintenance, change an air filter, and you're ready to go. Laser mill coming in 2017. Next to that, we have our impression scanner. This is the Dental Wings I-Series scanner designed for scanning impressions, turning them into an STL file. Can be used in a dental laboratory to reduce the model room or close the model room, or can be used in a clinic office to take your direct impressions, convert to STL file, and begin your digital workflow. Next to that, we have our guided surgery platform, Co-Diagnostics, #1 here in Germany, and one of the most widely used guided surgery platforms in the world, Co-Diagnostics. Next, we're going to show you in detail after the intraoral scanner demo is our chairside design software. This is a new CAD design software built on the technology we've been building for 10 years in the laboratory, but designed and optimized for the chairside use for a scan, design, mill workflow. And then finally, we're launching here at IDS 2017 a line of 3D printers. 3 different models to fit every individual application, whether it be laboratory or chairside. Can print models, drill guides, restorations, temporaries, that sort of thing. But let's go ahead and talk about the star of the show, which is here center stage, intraoral scanner. It is, of course, all about the wand. Go ahead and put it back in pause for me, Robin. I want to show you a couple things about this wand before we jump into scanning. Notice the size of it. It's designed intentionally to have the same look and feel of a dental high-speed handpiece. You already know how to hold this wand. Notice the neck itself. The narrow neck is designed so that as you're scanning, you can see around the neck at what you're scanning. And that's right, we want your eyes in the mouth while you're working in the mouth. Most of our competitors, while you're scanning, they have you look at the computer screen. We want you looking in the mouth so you can see what you're scanning and keep an assessment of your patient's condition and comfort. Then notice the shape of the head itself. Not only is it just 5 millimeters thick, but it's curved, so you can capture multiple surfaces at one time as you're moving around the arch. And then in that head, you'll notice there are 5 independent projectors there. Each of those LED projectors you see is paired with 2 cameras, and each of those triplets composes 1 intraoral scanner. So there are 5 independent intraoral scanners in the head of this wand, all looking in different directions, allowing you to capture tight and proximal spaces easily. Last thing is that blue luminescent band. I'm going to hand it back to Robin. Robin, if you go ahead and start the scan process, you'll notice that the band turns red. That red luminescent color tells us that the wand is ready to capture data. It's actively looking for anatomy. As soon as he went into the mouth, it turned green. That tells him that his wand is capturing data. He does not need to look at the screen to know he's capturing data. And if you look at the screen behind you, I want you to look at the speed at which he's capturing data. That speed you're seeing is the result of a software upgrade that we just launched. That software upgrade, a bunch of new high-tech mathematic algorithms that our developers came up with, that upgrade is going out to all users next month, and it doubled the speed of the camera. Now you'll notice Robin is reviewing his scan without touching the unit itself. There's a full gesture control unit built into the top of the scanner that allows him to review his scan without taking his gloved up hands and touching the unit. So infection control was a big part of the design process for the intraoral scanner. He's now taking that cloud of points and turning it into an STL file. Your STL file is created right here on the scanner. You don't need to send your scan off to anybody else to create an STL file. The workflow on the left side of the screen prompted him to move on to the upper, which he's now doing. And again, make note of the capture speed as he's moving around the anatomy. He's able to move fluidly in whatever direction he wants. There's no prescribed path. And he's able to capture everything he needs in a matter of seconds. And again, review it with gesture controls. When he moves on to the next step in the workflow, it's going to prompt him now to take an occlusal shot, a bite shot, not occlusal, a buccal shot for the bite. This is simply going to capture the buccal surfaces of 2 or 3 teeth on both arches and then use those surfaces to pair up the upper and lower scans in their proper articulated position. So he comes in, patient closes, comes in next to the cheek, does a very simple shot of those buccal surfaces. Again, 2 or 3 or 4 teeth, upper and lower, come back. And then he hits next. Again, that cloud of points is converted to an STL file, and it's going to automatically move forward to the matching of the previously taken upper and lower scans. Here we are on the alignment screen, and you see the scans are paired up perfectly. As we hit next, we go to the prescription screen, review screen, sorry. We're here on the review screen, allows him to open and close the articulation. He can zoom in on the prep site and check for occlusal distance, the distance to the opposing. This color map is telling us that he has prepped the tooth enough. If he had not prepped it enough for our restorative material choice, then you would see some red or orange on that occlusal surface of the prep. If that was the case, we could very easily lock the rest of the scan, preserve that margin, go into the mouth with our handpiece, our high speed, reduce the prep a little more, then come back in and rescan just that prep. No need to rescan that entire quadrant. We also have a tool, we move forward, that's okay. We also have a tool to automatically check for undercuts on your prep. Here we are on the prescription screen, where we can choose the crown, we can choose the material, go to like a Vita or a Namic, whatever material you want, and choose a shade. While we're talking about shades, I'll point out that on the chair in front of us here is a shade taking device. It might look very much like a Vita Easy Shade system. It actually is, but in Dental Wings Blue. It's in Dental Wings Blue because it's going to be integrated into the intraoral scanner. So you'll go in the mouth, you'll take your shade, and that shade will be delivered to the scanner automatically and become part of the prescription that goes off to the laboratory. And if we hit next one more time, we're going to jump into the DWAS Connect screen. So this is the DWAS Connect screen. This is our cloud-based case transfer system. It's going to take the STL files that we captured, the upper, the lower, the bite, as well as the occlusal scan that we've created from that, transfer those to the laboratory, but included with those scans are any kind of file attachments we want. We can reach out to our network, grab a smile shot, we can take a picture with the integrated camera, we can add voice notes to the system, and all those voice notes and pictures and file attachments, along with the prescription and shade information, patient demographics and due date, all gets bundled with the STL files and sent to the laboratory at no charge. There are no scan fees, no monthly fees, no license fees to keep the scanner going. When you buy the scanner, you've got access to all these tools. And now we want to switch over and have you take a look at our chairside design software. So you've captured the scan, you can send it to a laboratory, or you can incorporate it into a scan design mill continuum in your office. So Robin has just switched over to our chairside design software. And Robin? Take the remote. Okay. We're about to lose our TV. Okay, so we've launched our chairside design software. And this is a software application that's been built on our 10 years of DWAS CAD development that we've had in the laboratory. But it's optimized for use chairside in the clinic by doctors, can help you design a tooth in 2 to 3 minutes. Imported the STL file. We need to adjust the margin line. There are tools available to do that. And Ruben is adjusting the margin line right now. You can see it's got an auto detect. He just brings that circle closer to the margin and it detects it for him. Moving on from there, he's going to set his path of insertion. And you'll notice there's also undercut detection here. So he sets his path of insertion. Moving on from there, the software is going to actually analyze neighboring teeth. We're not just going to drop in a generic tooth from a generic library. We're actually going to analyze the patient's own dentition and develop a restoration that fits in that mouth. That's what you see the software doing here. It comes in and you can see a color map showing occlusal interference. All the tools are available for adjusting that occlusion, adjusting contacts, shaping and morphing the tooth as needed. There's an automatic occlusion adjustment, or we can take those hotspots down individually. We can, again, adjust the cusp, adjust the tooth dimensions. So all the tools that come with the 10 years of DWAS development are here, but in a very easy to use, intuitive interface to just make a decision, move next. That was the auto occlusion adjustment you just saw. You can adjust translucency, of course, of the neighboring scans. And then as we move forward, the restoration is automatically dropped into our CAM module, where you can adjust where you want the sprue attached. You can adjust how you want the sprue attached. And then you can send that CAM file directly to the laser mill or the mill of your choice. Thank you very much. If you want a detailed demonstration on any of these technologies, the two we highlighted or the other ones here, we have demo stations running up the aisle this way and also behind me. Thank you very much for your attention.